Number 12, the series n equals 1 to infinity, n minus 1 over n squared root n. The first thing I want to do is simplify the denominator. So I'm going to rewrite this as the series n equals 1 to infinity, n minus 1 over n to the 5 halves. So I combine the n squared and the root n. And now I need to find a series to compare it to. I'm going to start with the numerator. So I know n minus 1 is smaller than n. And then I'll divide through by n to the 5 halves. Okay, and then I'm going to simplify this n over n to the 5 halves. That gives me 1 over n to the 3 halves. So this looks like the piece from a p series, and my p would be 3 halves, which is bigger than 1, which converges. So this bigger piece here converges, which means the smaller piece that I'm interested in also converges. So I'm good to go to start my write-up. Since 0 is less than or equal to n minus 1 over n squared root n, which is less than or equal to 1 over n to the 3 halves, and the series, the sum, n equals 1 to infinity of 1 over n to the 3 halves. So I have a p series, and my p is 3 halves, which is bigger than 1. So that converges. Therefore, so you can use the 3 dots as a therefore, or you can use the word so or something like that. The series n equals 1 to infinity of n minus 1 over n squared root n converges by DCT for direct comparison test. That gives us number 12. Take a look at number 13. So number 13, I don't need to simplify this one. So, and my numerator is pretty simple. So I'm going to start with my denominator. So I know that 3 to the n plus 2 is bigger than just 3 to the n. And then I'm going to take 1 and divide it by both of these sides. So 1 over 3 to the n plus 2. When I do that, that flips my inequality over. So I have less than 1 over 3 to the n. And I'm going to simplify this 1 over 3 to the n. That's 1/3 to the n. So now I have a number raised to the n. So it looks like a geometric series. And 1/3 is my r. It's less than 1, so it converges. So again, I have this piece that converges, so it'll force this to converge. It means I'm ready for my write-up. Since 0 is less than 1 over 3 to the n plus 2, which is less than 1 over 3 to the n, and the sum n equals 1 to infinity of 1/3 to the n, that's going to be a geometric series. Absolute value of r is 1/3, which is less than 1, so that converges. Therefore, or so, the sum n equals 1 to infinity of 1 over 3 to the n plus 2 converges by DCT. And there you have it.